At the JET test reactor near Oxford, England, scientists are developing an energy process completely different to nuclear fission. It's called nuclear fusion. Fusion works by heating different particles of hydrogen to super high temperatures. When they get hot enough, the particles fuse together, releasing enormous amounts of energy.
You have to find some way of getting this material to enormously high temperatures, 200 million degrees centigrade. At these temperatures, matter enters a new state, a state called plasma. Over these last years, we have learned how to control most of the processes, how to heat the plasma to the temperatures that are required, how to confine it well enough, how to keep it free of the impurities. And we're ready now to go forward and show what this means in fusion terms.
The JET reactor is still experimental. It can only generate power for a few seconds at a time. But for Alan Gibson, such an achievement is significant.
To our delight, this thing worked beautifully. According to our expectations, we produced real fusion power, 16 megawatts in a pulse lasting about a second, 4 megawatts in a pulse that could have lasted as long as we chose, but we chose to switch it off after about 4 seconds. This, for us, is a real advance.
Nuclear fusion is highly energy efficient, and it's environmentally very friendly. But crucially, nuclear fusion is also extremely safe. In the future, reactors like these could never melt down. So, no meltdown, no contamination. Science, it seems, has found a solution to the potential danger of nuclear power. But there's a problem: time.
First of all, we need an experimental fusion reactor generating fusion power, keeping itself hot, self-heating. And only after that can we go to the series production of a set of power stations. Now, each of these steps takes about 15 years. So you can see from this that it's going to be 30 to 40 years before we have power stations that can make a contribution to our energy economy.